jumping onto the demo, the first of two slides is just to set the scene. The HOODIE shop has 4 main tiers. There's a front end Node.js, back end Java Spring. Both of those just run on VMs, Google Compute or EC2. The database starts to use some of the cloud specific services. It's a SQL instance and an RDS Aurora in Amazon. And at the analytics layer, we've got Spark, Dataproc, or EMR. There are 2 ways to slice it when we're working with multi-cloud. Sometimes it makes sense to say, here are all of the tiers running in cloud A, all of the tiers running in environment B. Other times you might want to do it on a tier by tier basis. For this, we've modeled it as a tier by tier basis, so we can fail over individual tiers if we want to, and we'll do that in today's demo. We support both. We try to be very agnostic. AMP can be used to model things as they need to be without passing too many opinions. So going just a little deeper, and then we'll promise we'll cut to the chase. Within that Spark tier, there's an element called the Spark tier, whose job is to manage the different tiers in different environments and ensure that one of them is primary. It's got a primary election policy attached, and it's providing a consistent view. We call effectors the things that we can invoke. So there's a consistent way to submit jobs and a consistent view of sensors. In this case, it's just the UI, the endpoint that we need to get into it. That delegates to something that, depending which location it's asked to produce it in, it will do different things. In Google Cloud, it will run a Terraform Spark that uses Dataproc. And in Amazon, again, it's using Terraform, but will stand up in EMR. Now, we use Terraform here because we like it, but CloudFormation, ARM templates, custom scripts, Ansible playbooks, whatever's needed. I think Simon had said that in your world, there's a lot of cleverness that goes into figuring out when to use spot instances, where to run, how much to run. We don't want to get in the way of that. We would call that in the same way we call Terraform. So this is Cloudsoft AMP. You come in, you've got 3 main parts. There's a composer where you can build these things visually, flip back to code. It's bidirectional, save that code. We tend to use a hybrid approach where some things are better done graphically, some things we prefer to edit, put it into our favorite IDE, put it into GitHub. Standard processes for declarative, but there's a visual tool that it actually ends up being quite useful in a lot of cases to help fill in things. It also lowers the barrier to entry for people who don't want to know the details. I just need to fill out, I need a medium-sized t-shirt Spark cluster, please. They can drag and drop from the palette, pick their t-shirt size and hit go, or stitch it into the application. The dashboard provides a high-level view of the applications that we're running, surfacing things like the endpoints that we're using, primaries, what are the policies doing, how's the compliance. We'll make heavy use of that. Then the inspector gives very much a debug view, a deeper view to everything that's actually going on. Talk is cheap. This is the composer, and I can drag things from the left to the right. I can pick on things on the right and edit their fields. I can define new items with custom fields. So t-shirt size could appear at the right if we wanted a t-shirt size parameter for, say, the Spark cluster. And then you can deploy it or save it or flip to the code. This takes a few minutes to create. So I've gone ahead and deployed it. And so we'll flip to the app dashboard. In this case, I've got 8 applications running, but the one we're interested in today is this Cloudsoft HOODIE shop that's using Spark. So I'll drill into it. If I come to the information tab, got policies running, primaries, we'll start with the endpoints. And these are configurable. It's up to us. These are the ones we chose to surface because it makes sense for this application, but you can add whatever type of information and compliance checks you need. Well, it's telling us that the primary DNS is pointing at 34.140 in Google. We've got a URL. Let's go ahead and click this. The application is running. It's live. We have a catalog. It's pulling in t-shirts from various, or hoodies from various systems. It's connecting to the database in the back end to service this. and it's forwarding a lot of the request analytics into Spark, into the database where the Spark jobs run against. I won't spend too much time in the HOODIE shop, but the interesting thing is that it's in Google, it's using Spark, and here we have the details on Spark. Now there's a lot going on down in the weeds to make this Spark cluster, but our current primary is running here. And we can open that endpoint and go straight in to see the history server for it. Later in the demo, we can do failovers. If this fails over, this will just immediately redirect to Amazon. The same link and user experience coming into AMP will give us the different endpoint. More interesting, we've done the same thing at the effector in order to submit jobs. So from this point, I will flip to the inspector, where we have a much more detailed view of everything that's going on. We can see the DNS, each of the tiers, specifically in the Spark tier. We started it running in both Amazon and Google just for speed. See, most of the time you would not want to pay that cost. You just run in the one location that you prefer, but with the confidence that you can fail over if you need to. Down at the level of the Spark cluster, we have created a submit job just to facilitate submitting a job. Most of you probably know the way you want to submit jobs does vary between Google, they prefer the gcloud command, Amazon EMR, and plain old Spark. It would be nice if the same thing worked everywhere, but it doesn't. But AMP tried to smooth that out. So the submit job effector, here I can configure it with the main parameters that we want to pass. This will just translate to running a gcloud command to submit our jobs. But I'll go ahead and submit our jobs. The debug view will show me lots of gory details about what's actually going on. I can see the standard in, the standard out, so we can track the job as it runs. That's all in the standard out. So here's the job output going through. We can flip over to the history server and see the job running there. But that was the Google specific way. I'll let that run, do its thing, but flip over to show the consistent experience. At the level of the Spark cluster, I have the same effector, but no parameters, because the parameters are different, the way you want to install things. But in this case, it's a standard job that we're running, so we can use the defaults everywhere. This will submit that job. It's set up, whichever is primary, it will run it with the defaults. So if we do need to fail over to Amazon, this way of interacting will still work. Obviously, everything you're seeing in the GUI can be done through a command line tool that we have and through a REST API. So it's easy to script for that consistent behavior. So coming back to the slide, so we've shown how we get portability. We can go into some details about how these get built if we're interested, but the key takeaway is that we've got different implementations, but we're smoothing out those roadblocks and giving a consistent view of how do we get to it, how do we use it, but with as much detail as we want underneath. Now that's still fairly low level. Where it gets interesting is where we want to show that, yes, it is running. So that comes to the compliance tabs. We've put in 2 compliance checks. We're going to require that we say we support Amazon, but we need to show that to the regulator. We also need to have confidence ourselves that it actually does work and it hasn't rotted. Amazon's pretty good about, if it worked now, it's probably going to work in a year's time. Google like to move faster and break shit. So Google One, you might find in a year's time, if you've not tested it, it's going to rot. If your primary is Google, that's not so much of an issue. You'll discover it sooner. But to have confidence, we recommend that smoke tests be performed periodically. In this case, the policy we attached said each tier that we claim can work in an environment needs to be smoke tested monthly. But initially, it's got to be done within 48 hours of deployment. So I can do that here. I click the detail. We'll pick the, let's pick on the front end. The front end is going to expire in 2 days. Let's go ahead and run it now. I can click this. That's just going to redirect me to the app inspector so that you have a deeper understanding of what's going on. We can come here, and at the level of front end, let's run the smoke test in Amazon. And you can, of course, have a policy that ensures that this runs every month. This simply ran a couple scripts that we defined, generated a report, uploaded the report to a Google bucket, and it's also updated the compliance sensor. So if we come back to the dashboard, we now see that this is passed. It's good for 28 days. And if we drill in, we can run it again. We can view all the gory details that AMP is capturing of the last run back in the app inspector. So I've jumped around a little bit from different hats, but if I've got my compliance hat on, I don't want to be seeing that awful inspector tree and the output of all of the scripts. But I do want to know there's a generated report that I can show to the auditor. If I'm the engineer who needs to figure out why it failed, I absolutely do want all that gory detail that we saw previously. But if I click on the generated report, that's connecting, downloading the bucket, result is pass. And we have all the detail of the state that the justification for why we confirmed it passed. And again, that's going to vary from environment to environment and system to system. But that the way that you use it and interact with it remains the same from the app perspective. So we've got consistency about how not only how we set things up to run, but how we ensure that they have run and how we surface that to the regulator. The final area was resilience, and you may have seen that we've got these primary tabs. We've started with everything running in Google. We've set this up to be a very aggressive and fully automated. That's not necessary. We do pull sensors from whatever sources you need. Part of the blueprint can say connect to New Relic and Dynatrace and run commands on the box and take the Terraform output. What we want to do is be that central focal point where we tie it together with the right topology. So things are discovered at the right level, accessible at the right level, and then be able to attach policies. So the other policy is the primary election. And we can trigger that simply by, we'll pick on the front end. If we force the Google front end to stop, we have said that we can fail over within each tier. In the real world, some things you might be relaxed about just failing over automatically. Other things you'll want to surface in ServiceNow. We'll create an incident. Yep, this is down. It needs attention right now. People get paged. They confirm, yes, it is down. The right thing to do is failover. And then they might just click the effector. So we can still automate the failover. But that should have happened up here at the front end. We can see that there has been a new primary election 3 minutes ago. We can view all the details. The management tab gives a little bit more information. The primary was reelected because one of the entities told us he was no longer true. It selected AWS. This is with my operations team hat on. If I flip back to the dashboard and put my high-level manager, what the hell's this system doing? Well, I can see, oh, the front end is now running in Amazon. And if we flip to the endpoints, we can see that actually now it's using this DNS, allegedly from AWS 1. Let me just check that the HOODIE shop is in fact still running. And it is. That's good. We've still got all of our hoodies. Was it actually doing the right thing, or was this smoke and mirrors? Well, we've got a who is check. So I'm opening here just a third-party whois tool, confirming that that IP address now is in fact belonging to Amazon, and that is the one that the DNS server is returning. So the failover was real. There was a little bit of kind of might seem like magic. It's pretty straightforward. There's a dependency injection and subscription going on behind the scenes in order to ensure that when that front end failed over, the DNS Terraform also got reapplied using the latest values. So we're taking care that primaries do trigger failovers and promotions elsewhere where needed. again, that's just part of what we mean when we talk about policy-based management, being an orchestrator of orchestrators. We're leaning very heavily on infrastructure as code and scripts, but trying to surface that in a way that gives people a consistent and familiar experience. So to just recap, on the audit side, we saw that we have smoke tests that give us actionable errors, either on failure or when deadlines pass, not getting in the way of any of the logs, but making it easier for people to get to. And this, of course, can be synchronized to ServiceNow and other tools. And on the resilience side, this is, as I said, one of the main use cases. One of our customers has done their payment system and various others. It's estimated just with one application, they used to have 4 people running around making sure that all of the servers are running, that people are aren't having problems fixing issues as they come along. It was full-time for 4 people, put in place a lot of the automation, invested in building the resilience policies. And that's now down to 1 person, 1 day a week, fixing the irregular issues, trying to put those into new policies that AMP can run to further reduce their time. But the rest of the people are now looking at how AMP can be used, not in firefighting mode, but to drive optimization so that customers either get better performance or you're driving down costs. So hopefully that's made sense. I've gone through it very, very quickly. I appreciate. I'd love to go back and talk about anything, but I wanted to give you a sense of how we think AMP could help with the challenge that you've described about needing a Spark to run reliably in different environments, being able to use the sophistication in Google, but having something that's aware of EMR, maybe day one isn't super complex, but where people can invest in the Amazon EMR Spark and make that all singing, all dancing as it needs to be, attach the resilience and compliance and package those up as reusable pieces so that it doesn't have to be reinvented for each team.